of No Orientation Programming. I'm Joe, and today we will continue our simulation process. I'm a little bit tired, but still motivated. Yeah, so what are we doing? We create the PC part of our audio processing project. Where is my glass? One moment. I'm back in a minute. Yeah, so now we can start. Last time on Tuesday we started the visualizing process. Actually, I think it's more an user interacting process, but we will check later. Oh, okay. And so we started the first process, and the first process at the moment is called ESP visualizing. And we created the process physics animating. And last time this process was started by simulation main, the ESP simulating process here, but actually this process should be an abstract process with the pure virtual function animate. And the process ESP visualizing is derived from physics animating, and this process should implement the animate function. Because we want to implement the basic behavior in this base class, and then we want to use the convenience function which are included in the base function, or the base class. So, yep. Cheers. Okay, so the base class, the name of the base class is cool already, but I think we should rename the process ESP visualizing to something else. When will we do Rust? Tomorrow I will continue reading the book. Tomorrow will be a long day reading the Rust book. Hi, Kuchenmann, Cake Man. Hello, Cake Man. By the way, nice to see you. So I'm quite curious if I will like Rust in the future. Today I finished the first Rust program, as you saw, and yeah, today it went better. On Tuesday it was, I had my issues and my problems, but today was quite, yeah, I was reading and writing, and I understood some stuff. Hopefully in the future I will understand all the parts in Rust. Actually in C++ at the moment, if you want to understand C++, all the standards today, then this, I think it's harder. It takes much more time to learn C++ than learning Rust, I think, because in C++ there are so many concepts, and I know Rust is hard to learn. I think it has some things you have to grasp, but actually the amount of things that must be considered is more in the current modern C++ implementations. So we will see. I'm quite curious how this will go. But in the stream, I don't think that we will ever see Rust in here. Only in the case the Rust language is completely turning me around and making me to a Rust zombie. This is possible. I'm not sure if this religion will eat me alive. So I have divided the physics animating process into two parts. The first part is the base structure. The base structure can be seen if we start the app. Then this is the base structure. The base structure consists of the left part, where we have our options and controls and the buttons and stuff, and on the right side we will have a screen for printing. That's the base structure, but that's the base definition. Or the definition of the base structure is done in this physics animating base class, and the rest, which buttons should be displayed, is on another process in this ESP visualizing process. But actually it's not a visualizing process. We should rename this. The naming is not perfect. So we will change this to CPP rename ESP visualizing to sim user interacting. Yes. So the user interacting process, if we have a user interface like this, then two things should be paired. The input area and the output area are two things. The processing of the button inputs and the visualizing stuff should be one unit. And the units like this I'm calling the interacting process. So load, look, it already changed my file. Oh, nice. But I guess it didn't change the meson. Visualizing, yes, sim user interacting. So let's see, it's compiling and still starting. Okay, that's fine. Okay, file animating should be on the user interacting should be on the right side. So today we want, what is our next task? The next task is to implement a function that is called like in the Dirac animating. Let's try to implement this function UI slider add. This function is, I think it's a protected function. I think it doesn't, yeah, Okay. So this should be I don't know at the moment. I don't know which signature we will use later on. Let's see. What is this function doing? It's creating a slider, yeah? Okay. So we have the self. I hate this self in Python. That's so uncool. So we have the first number is the max value. The second one is the start value. The third one is a bool if it's two-sided, between minus 100 or plus 100 or 0 to 100 times R max. And then the prefix, the label, and the unit. And I'm not sure if we should make a pointer as return type. I'm not quite sure. Yes, maybe. Maybe UI slider add. Okay, so UI slider. What is a UI slider? So the return value should be a pointer to something. Should we make a pointer? Yeah, why not? Okay, let's make a pointer. We can look in the file animating. That's a cool slider, yeah. A cute slider. The cute slider class. Okay, another thing we should add on the literature. The cool slider class. So main window, grid, push button, and doc cute IO. That's the damn it. So so cool slider, and this is the include. So we have to add the include in here. Grid layout, push button. Here we will add all the stuff we need. So here, yep, nice. This function will create the slider, maybe. If it is successful, it will add this to our options automatically. So and this will be done in the user interacting process, and that's it. So that's the push button. We add the widget, yes, here for example, but we don't need this on if we are using here for example. We make a cool slider pointer MP. Let's call it time, or no, frequency. So this is our new pointer, is equal to something, and here is equal to null. And then we say UI slider add. And then if not, then we say could not create slider. And here we say for example, the same. I don't know if we should how often do we need this parameter? I'm not sure. Maybe we should we exchange the parameter, or should we change the parameter order? I'm not sure. I want to remove this tab. That's strange. I want to make this as an optional and this thing as well. Yes, I don't know, maybe. Let's try it. These values should be a float, I guess. I think float is fine, hopefully. Yeah, I'm not sure. Yes, it's a float, I guess. Is it a float? Actually, it's not important, I think. Q slider. What is the value of a Q slider? Q slider. Come on. Value. Value changed. Value. Tick position. Q slider. Value. Into an integer within a legal range. So let's see. Here we have the R value. SL frequency, R value. Value changed. Value changed is process. What the hell? Okay. If that's strange. That is strange. Oh yes. Okay. That's Python. Okay. Python is completely different. So R value. UI labels update. Okay. So this is R max multiplied and divided, so it should be in float. Okay. So float max. This is max, I guess. So value max. Let's call it value max this time. Then we have float value start. Then we have should this be a const string reference? Should we make a const std string reference? String label? I don't know. And another. I'm not sure. Let's see. We could try to make a string unit, and then optional. We make that's optional already. So we may not want to create a unit and then a bool is two-sided is equal to false. let's see. Here, this is our function, and so now we create this thing, and similar to here, we say Q slider P slider. If not P slider, return null. But if we have a slider, and of course we need a Q slider, a new Q slider. And what is this MP window? What MP window? New Q push button. What? Interesting. Let's try something. If 0, I'm not sure if we need this if we need this line, because no. That's interesting. That's interesting and strange. Maybe we just need to do this. That's interesting. We will check this later. Q slider, because on the slider we have inherits abstract slider, and I think this inherits QWidget, and QWidget has a constructor with the parent pointer. And the parent pointer, I think we don't need to, I don't think we need to make this if the options are the parent already, but let's see. I will finish this thing. So here we have our MP opt, I guess, and MP opt should be a member function of the base class. That's cool. Q slider has a widget. No, has so public functions, parent as null pointer. Okay, we have created as a push button, and the push button has a different constructor. The constructor here, we have another constructor, text and null pointer, and parent, text and parent. So this is different to this one. Here we only have an orientation, interesting, and a parent, but we will only use this version, so we only have here the parent. We will just leave this as it is, and here we just we just add the slider at this point. So we have a parent. If we were not able to create this, otherwise we say P slider. And for P slider we say we want to do something else. We need a Q label as well. Okay, as you can see, what is this? Set single step. Set single step. This property holds the single step. The smallest of two natural steps that an abstract slider provides and typically corresponds to the user pressing an arrow key. An arrow key. Set range, okay. That's cool. Set range. Let's say if is two-sided, then we have set range this. Otherwise, we have 0 and 100. Okay. And we can set the value, I guess. The value. Set value. There must be a set value. That's the abstract slider. Set value. Yes, perfect. Come on. This proper holds the slider's current value in integer. Then forces the value to be within the legal range, minimum value, maximum. Changing the value also changes the slider position. Okay. Nice. So, and this must be an integer, yeah. So, we say slider integer. And this integer must be 100 divided by 2. So, okay, set range. We should do set range first. Yeah, set range first, that's fine. Set single step, that's strange. Set single step. Only 4 steps. Or is it? This is strange. This is somehow strange. Okay. We could... we make a... it's done after the set range. Okay, after the set range. We should check this later. And here we have value start divided by value max. Hopefully this is working. So, and now here we have options add widget, but I'm not sure of, if we need an add widget here. Maybe. So, and at this point we say void string label and void string unit. Because I just want to test this for a moment. Let's try to compile. Okay, default argument given for permanent float. What? Default argument given for parameter 4 of slider. Yes, why not? Ah, yeah. Of course. No matching function, new slider. What? No matching function called to slider VBox layout. Okay. Okay, this is not allowed. So then we say MP window because it's a widget. But as you can see, we have a slider here. That's strange. Okay. Interesting. Do we need a orientation? Yes. Cute horizontal. Aha. Interesting. So we have an abstract slider here, and the abstract slider has a parent, and the normal slider class has orientation and parent. Okay, that's better. So horizontal. Cute orientation. Cute orientation. So I guess we want to make using namespace cute. Hopefully this is working. And then we say orientation horizontal. Oh, look nice. So, but as you can see, this is not okay, and we cannot enter a VBox layout because it inherits a layout. So we have an layout, an object, but that's not useful for us. So we have to change its association. So I think this is needed actually. Add widget to the options. P slider, and then hopefully this is in the right position. Oh yes. So the parent gets changed somehow, because this thing wants, we are not allowed to, it's strange, but we are not allowed to, what it needs a widget, and the layout isn't directly a widget somehow. I don't know, and I don't care, but actually we need this. So, and this looks fine. Does it look fine? So it's in the middle. It's in the middle. Why is it in the middle? Because if is two-sided and two-sided is false, that's strange. No, because we said true. Because we said true, yeah, because it's two-sided. Yes, yeah, that's fine. So now we want a label, but this label should be in a certain position. Let's see. The label should be beneath this one. So we have time offset and then a value, and then okay. But looks fine. It looks fine already. Ooh, what's that? Label string plus equal some stuff, and then our start. What the hell? Oh yes, I understand. Yeah. Oh yes, yeah, okay. Okay, we want to add another thing that is called a Q label. Okay. So we have include of Q label, and Q label is fine, but I want to create this Q label if Labels update. Labels update. I have an association between that's bad. Yes, I understand. We have a unit consisting of the slider and the label. This should be one unit. But I don't want to deal with the label in any way at the high level process. I just want to use this slider and change it, and then I want to read the value, and this label should be changed automatically. I don't want to do this in the high level process. Actually, if we change the parent, then we should not need to. We shouldn't be forced to use a temporary. Let's see what is happening now. Now we see nothing because we didn't associate the slider with any parent, but now we should see it and it should be fine. Oh, fine. So we don't need this the special constructor, but we just need the normal one. Yes. And here as well, hopefully. Yep, nice. Okay, so this is simpler. We just have to create this stuff and then add this stuff to something, to the options. That's enough. Okay, fine. What do we want to do next? Yeah, the label. We could make a set. And we need a connect function. We need a connect function. This connect function should change a label, and depending on the pointer of the widget, we should be able to directly associate the label. So I think we can use a set, hopefully. Include set. Let's say C++ set. So this is a std set. And this thing has a key value pair, and because the pointer is an unique identifier, we should be able to use a set. And we can insert something, and this should have a complexity. If a single element is inserted, logarithmic in size in general, but a modest constant. If a hint is given and the position given is the optimal. But in the worst case, logarithmic, and that's fine. Okay, if any elements are inserted in general but linear, if the elements are already sorted according to the same ordering criterion used by the container. Okay. Fine. Iterate and max efficiency inserting. Okay. So we have a list of labels. This list of labels is a member function std set of my set insert my set. What's a pair? Why do they need a pair? Read. What is read? No element, no new element inserted. Insert set. Insert blah blah blah. Insert returns a pair of iterator and bool. Return value. A single element version return a pair with its member per first set to the iterator pointing to either the newly inserted element or to the equivalent already in the set. The pair second element in the pair is set to true if a new element was inserted, or false if an equivalent element was already existed. Okay, so we need a pair as well. Do we care? I don't think so. I don't think so. Void, yes, void. Void is cool. No. We use this value, this type, single element, this type. Okay, and we ignore the position because we don't care. Okay. So we have an std set of what? A pointer of type QWidget pointer mlist labels, and here we should add the element. We should append or insert the pointer of our label or our corresponding label no, we don't need we do not need a set. We want a map. An std map. I took the wrong one. So yes, we need a key and an element. Insert. Example. A pair of do we need a pair? This is so strange. Why? Position and value. If we insert, what's the complexity? If a single element logarithmic in size in general. That's the same. Yeah, okay. Okay, let's make a map. And this map is character to integer, for example. Then we have a QWidget pointer, and we have an association between QWidget pointer and QWidget pointer. This is the widget, the source widget, and this is the label. List label. So, and we add this label to I don't want to use a pair. Do we need to use a pair? First insert function version single parameter. I guess we need a pair. What is the lifetime of this stuff? The lifetime of this stuff is we have a list and a list of pointers, and every pointer lives at least as long as our as long as our shutdown function. Okay, deleting queue window. Yeah, so here we have a clear, hopefully. This should be fine. C++, do we have a clear? Yeah, clear content. Okay, fine. So map is cleared here, and here I want to add something else. A function that is called a virtual success unim shutdown, and here we have this shutdown function. Okay, fine, and here we say return positive. This can be overloaded, and here we say success, and here we say success is equal to unim shutdown if success is equal to pending. We say return pending. If it is something else, then we do the rest. Then we know that our high-level class is finished. We can clear all the stuff. We can delete the window. We can delete the associations. We can delete the window. After this, these pointers are invalid. That's fine. And then we quit the application. This should be fine. Hopefully. Can we compile this? Yeah, at least. So at least it's still compiling. So, but now, if we want to add a slider, then we have to add the association. We add this association after we add the widget. Okay, so we say list, it's not list labels, but map labels. Yeah, list, yeah, map. Should we call it, yeah, map, list, yeah, don't know. List labels, map labels, whatever. So, yeah, let's make a pair. Map labels, insert, pair of, is this needed? Can't we just place stuff, insert? Okay, insert. I just want to say, do we have an operator like this? Yeah. I think this is possible. Yeah, nice. The pointer of the slider should be equal to the pointer of the label. We add the widget label here. We add the widget here. So we add another widget. Add p slider, and here we have p label. We add both widgets. We add the association earlier. Okay. Yes. Here we make the connection. Connect. Here we change the values. So at this point we say we have a q label, pointer p label, and this is created here. P label is a new q label. If not p label, then delete p slider, return null. Okay, q label. We need a q label. Q label. Nice, the label class. Push button, grid layout, doc cute IO. Come on. Oh, God, come on. Q label. Nice. Now we have a Q label, and this Q label has. Oh, we do not need a parent. Hey. Hopefully this is okay. I hope this is okay. Yeah, that's okay. That's fine. Okay. So, add widget. P slider, yes. We slider config, and then later we make the label config, and then we make the connection. Options. This has, yeah, that's finished already. Yeah, nice. Yeah. Okay. So label config, string label. So label has a function that is called set something, text or set. Come on. We use the function. Okay, we made a string, and this string was, yeah, that's not cool in this case. Q label, we used the text as Q string. Select the text. Can we say, oh, let's try something. We say Q label q label p label is dot set something properties text q string text text edit. I want what is set text format. This property holds the label's text format. Possible options. No, I just want to add the text. Set text. Oh yes, set text has set text a const q string reference, and hopefully this q string has an constructor of a normal C string. Const char pointer. Oh, nice, perfect. Mwah. And a normal string, I guess. Yeah, q string reference. Yeah, I guess it's normal string should be fine too. Okay. So we say set text, and then we have some hello world. In label, which is pointer to q label. Maybe you mean to use. Yes, that is correct. Yes, hello world. This is the label. Fine. Okay. So, and here I want to. Yes. I'm not sure. Should we use a normal string? Can we use a normal string like a string? Text label is equal to this thing, text label. Let's try if this is working. Oh, that's not working. Cannot convert a string to const. Wow. Okay. So we have okay, whatever. So I want this thing to have a buffer, but this buffer, I don't want to have this buffer on the stack. And I want this thing to be on. We have three options. Here we have it on the stack, and then here in this area we have it on the heap, and in this area we have it in the static area. Actually, yes. Yes, on the other side, yeah, it doesn't matter. We can do a small buffer character. Oh, let's make a Q string. Let's make a Q string. Yeah, let's make a Q string. Q string, whatever. This should work too, hopefully. Yeah, that's cool. That's okay. So. Okay. So, text label. Can we do plus equal hello? Is this possible? Yes, that's cool. So, at first we will add the prefix. The label. No, we don't call it a string label, but we call it string prefix. Prefix. Text label is, hopefully this is working. Text prefix. No match for operator. Come on. Yeah, so time offset. We should avoid time offset. Time offset SL frequency. That's strange. A copy paste error in Hertz. Okay, frequency. And then we will do text label plus equals, and then text label plus equal the value as string, the value as string. What r start as float, 2 points, 2-point float. Float to string. How can we do this in to string? 5 point. Yeah, but I just want 2 points. Oh yeah. 5.5. Using macros. Lexical cast. That's all. That's all. Nope. Stop. I will use the cheap C version. Character. Buff. Label. How big? 64. I don't care. So, doesn't matter at all. So we have n as n printf of the buff label size of this stuff, and then we have a format. This thing has a length of 20 at least, and then we have a space, and then we have a percent float in 0.2, and then we have this one, then we have a percent s. Then we have a string prefix C string, and then we have a string. No. Then we have a value. Then we need a value in float. So we have a format string, then we have this prefix, then we have the value, then we have string unit C string. Yeah, that's it. And I just want to set text as above label. Yeah, like this. So we need a label, we need a value, and the value is float. The value is equal to initial stuff. As integer. Yep. One moment. Like this. Perfect. Then we have an integer of value. Nice. And here we have value as float. Nope. Nope, that's wrong. That's wrong. That's completely wrong, because we just want the start value in here. A label, yes, our start. Back to the roots. Value start. Here we just have value start, because that's the float variant, and that's the integer of 100. Okay. Yes, and of course we want to have. That's ugly. 40, yes. Yeah, that's good enough. It's strange that this is. Okay, we have to connect the slider. At the time being, it's good enough. Okay, so at the time being, it's good enough. What is this? Convert float. That's the toString class. Push button. Do we need a push button? No, we don't need this anymore. Map. Yes, maybe. So now we need a connect function. So we have two-sided. The step. We have the add widget. We have the set value, add widget, configuration, connection, and then showing the stuff. Connect. Here we need another connect stuff, and that is, how can we connect things in Qt? Slider value changed. Do we have a value changed? Value changed. So emitted when slider value has changed. Value changed. This signal is emitted when the slider value has changed, with the new slider value as argument. Signals and slots. Yep. Scroll bar value to, yeah, Counter, a small example value. Yes, emit, Oh, okay, Q object connect. Okay. Pew. Q object connect the reference of that's the pointer. P slider of Q slider value changed, hopefully, to this would be cool. Set value. Can we do set value changed? Label. Set text. No, we can't do set text because that is that's a set value changed, new value, and set value. Yeah. That's an easy example. So we do need the mapping. It would be cool if we were able to connect value change to label set text, but it's not possible. I think because we just need but to which should we slider value changed connect UI labels update. Haha, that's so bad because I update all the labels. No, I don't want to update all the labels. Yeah. I want to it's so strange because I want to know I want to have the direct association, which was the calling object of the signal slot. Actually, I don't like the signal slot system that much. Unique connection. If you pass the unique connection type, the connection will only be made if it's not a duplicate. Slots connect, the connect function. I want to have the connect. Object class, bus connection class, signals and slots. Object class. Do we have a connect? Yeah, the sender pointer. Which one are we using? Pointer to member function signal functor. So a sender. We need something like this. The context. I want the pointer, the context pointer somehow. Yes, I want to have. I want to have something like this. Const. It's a queue object pointer. That's bad. So I only we need to be a queue object. Can we be? Can we derive from queue object? Queue object, is this possible? Let's try. Base class should be initialized in the copy constructor. Okay, maybe, yes. Fine. Queue object part. Because if I am a queue object, I can receive signals. And if I receive a pointer as base class should be. Yes, because here we have the same problem. Okay, now I'm a queue object, and if I'm a queue object, I can receive signals. That's cool. And if I can receive signals, then hopefully I can get a signal with a specific context. Ooh. So, the sender is a slider with the signal value changed. And the receiver should be me, and with the function member function void slider updated queue object pointer p slider p object and we want to have the pointer of a file animating slider updated function. And if I have this thing, then I can use this pointer, the slider pointer, the source object which has emitted the signal, and then I can make the association in the slider updated with the help of the map. Shoot. And yep, Q widget, that's the source widget, and that's the label. Okay. Yeah, let's try. Come on. Yes. Let's see. Void p object. Let's see if this is working. I guess that the signature is not right. Static assertion failed. Signal and slot arguments are not compatible. Check compatible arguments. Signal type arguments value. Yes, because I guess int value must be added, hopefully this is the only thing we have to add. Pointer. The slot requires more arguments than the signal provides. The slot requires more arguments than the signal provides. Okay, argument type is wrong, but here we have static signal and slot arguments are not compatible. Check compatible. Arguments, signal type arguments and slot type arguments. Okay, so the number was correct. The number was correct, but the arguments... can we do a Q slider? That would be better. This would be nice. Oh, perfecto meas. Oh, nice. Cool. P slider. Then we have the pointer directly. So, oh, wonderful. Oh. Almost. Okay. Connect. Connection type. Signal, the label or abstract slider has value changed int value. Please do not tell me. Please, int value. Int value. Is this possible? What? QObject is an inaccessible base of phi animating. QObject is an inaccessible base of phi animating. Ah, yes, I understand. Yes, that's correct, because this thing... Hi, slime swallower. I tried to connect. I tried to make a connection in Qt. I want to connect. We have in our C++ application, we have a slider already and a label, and I want to connect these two things. So as soon as I change the slider, I want to update the label. And at the moment, I'm not sure how we should do this. I have a base class, the phi animating class. If I add a slider with the function UI slider add, then two things are created and added to this part of the user interface. The slider is added and its label. And in the higher level process, I want to just get the pointer to the slider. I don't want to deal with the label at all. I just want the pointer to the slider. And the slider should be internally in the base class, should be linked automatically into the label. So, and that's the struggle at the moment. But I think we will disconnect. Okay, we need one of the connection functions. And actually I just want to pointer to member function. I just want a function. I want a static function. Actually I want, what's the issue? I can't connect the slider directly to the label because I want, as soon as the slider signal value changed is emitted, then this signal can be connected to a function which receives an integer. But and with I want to connect this function to a destination widget, and the destination widget is the label. And this destination widget has only the function setText. Somehow we want to execute the function setText of the label. So we cannot connect this thing directly. I want to bind the signal of the slider, value changed, to a function with something like this. Slot. It's in Qt. It's called signal and slot function, and this slot function should have in something like a pointer, Q slider. I want to have the pointer of the source of the emitter. I want to have the pointer of the emitter, P slider. And if I have the pointer to the P slider, I don't care if this is a static function, because then I can create a static function, static something. And if I can bind the signal to a static function, then this would be fine, because then I can make an association to the label with Q label pointer P label is equal to m map labels of P slider. Give me the label corresponding to this slider, and then I can say P label is equal to set text, boom, boom, boom. And I can create the text here is equal to, that's what I want. Approximately in this direction. And in how did I do this in yeah. I connected, yes. That's strange. In the Python version. I connected the this value changed of the slider, the value changed signal. I connected to my function, to a function of my class, and it was possible because I am derived from QMain window, and I thought that we are able to connect if I'm at least a Q object. But here it says Q object is an inaccessible base of phi animating. Maybe I have to say public. Maybe this is just a problem. Yeah. Damn it. proc info log value is equal to damn it. It's working kind of, but as you can see, and that's so bad. That's the reason why I connected in the Python version. I connected to the function UI labels update, and the function UI labels update is updating all the labels because I don't have the context. So it's working kind of, but I actually want this pointer. If I have this pointer, then I can associate the label pointer with a complexity of logarithmic to the size of the map, and then I can directly change the label. I don't want to update all the labels every time a single. It's not that bad because we just have 5 or so labels, 10, let's say 10 labels, and we update 10 labels, and with the mouse I only change one label, one slider at a time, and then I update all 10 labels, so it's kind of okay, and it was good enough for me on the Python version, yes, but maybe we are able to connect this thing a little bit better, and I see something like so we have a sender, a pointer to member function signal, pointer to member function signal, const object receiver, pointer to member function method, connection type. This would be cool. Context, what's that? Functor. Context and functor. What's a functor in Qt? I don't want to have the value. I want to have the pointer. Q object context. The context, I think it's this. It must be one of these 5 types. Sender, pointer, signal, const char signal. Okay. Receiver, const char method type. Yes, strange. Sender, signal, const char signal, method. Strange. That's the point. That's the name of a method. Okay. At the moment, I think we have this type. We have used this type, and here const sender pointer to member function, and here we have a functor. What's a functor? We have to know what is a functor. If this is just a static function, then I'm kind of a functor. Differences between the functor-based connections. Double spin box value. Slot. Error. The string in the table doesn't contain value. What's a functor? Show. Q widget parent text sender. To QML. Slot with fewer parameters. What? Using default parameters in slots to connect signals with fewer parameters. Selecting overloaded. In contrast, functor-based connections are checked by the compiler. The compiler catches error at compile time, enables implicit conversion between compilable types and different names of the same type. For example, only the functor-based syntax can be used to connect a signal that carries an int to a slot that accepts a double, as Q slider holds an int value, while a Q double spinbox holds a double value. The following snippet shows how to keep them in sync. Slider double spinbox, set the value double. Ah, okay, that's the functor, ah. Get sender. How to get sender widget with a signal slot mechanism. Use QNAP sender in the slot, like in the following example. Connect signal clicked this slot. Main window, some setup function foobar button. Okay, looks nice. This we are a object. This slot button pressed slot. Check with mem. No way. Come on. Is it this simple? Is it this simple? Maybe. Okay, slider updated. Okay, we have slider updated. Maybe it's as simple as this. Q slider. Oh, come on. P slider is yes. And then let's check. I want yes. Q label pointer P label is equal to the map. Do we have a find function or something in the map? Do we have a find? Find map find, and we get an iterator. Yeah. So we have a map Q widget pointer to Q widget pointer iterator iter. And we say iter is equal to map find P slider if iter is equal to and return. Otherwise, P label is equal to iter. And here we say P label set text is buff label. And here we have the value. No. Oh, damn it. Damn it. No. Yeah, I need a struct. I need a struct. What that's one very convenient. That's a very convenient feature of Python, because you can use any. I can make a Q label. That's so strange. Actually, this can be much simpler. But okay. The cool thing is, I didn't know that I can get the pointer. I didn't know I can get the pointer from the from the sender. But in Python we are able to bind the information, the prefix information to the label object itself. So we can use any object. That's so strange in Python, but it's so powerful. That's so powerful in Python. We can create a cute object that is called QLabel. And then we have this object. We create this object and then we have this object. But we can say this object has a new attribute. We can call it prefix. We just say this object has a new attribute and we write this attribute to this object. So that's strange. That's not possible in Python. In C++. Yep. Yeah, then we have to make a struct. A struct that is yes, a struct is we need a struct. Damn it. Okay, struct. We call this struct. How? Label info. Whatever. Q object pointer P object. And then we say yep. std your string. Prefix, and then we say std string unit. And then we have the association between a source widget and a label info. Label info object. Okay, and we create this label info object here. We say label info inf dot p object is equal to p slider no p label inf prefix inf unit is there a unit and then we say inf and then we have the label info. Label info inf is equal to iterator and p label is inf p object, but that's a label. Yeah, no. P label Q label P label. We should not cast. We should not. We don't need to cast at this point. Source widget and label info. Yep. label info iterator, p label, and then we have info of the prefix and of the unit. Hopefully this is working. Now we get a lot of errors, I guess. Find p slider map. Find insert operator find b. We have a character and an integer. And what? In member function slider updated. Okay, here find slider. Label info. Oh yes, I understand, because it's a new iterator. Label inf. Oh. Okay, conversion from to non-scalar type. Conversion from pair, yes, that makes sense. I have to say second. Oh yes, oh nice. This no, come on. I have to add I have to add rmax as well. Rmax and value and divided by 100. Yes, okay, so yes, we need another one. Another information that is maximum. The label info is string and then float value max. And in the slider add, we say inf val max is val max. Perfect. And then we say value is equal to this. P label float value is equal to, the float value is equal to inf max value max times value divided by 100. Info max prefix, and then we have here value yeah, good enough. And here we have let's see what's happening. Unused variable. Yeah. Let's see what's happening. Oh, nice. 1 minus 1. Does this make sense? Yes, kind of. Because 1 is the maximum value. let's say 7. Yeah, nice. And let's see what is happening if we say, why did we set the set single step? What is set single step? This doesn't make sense somehow. What is happening if I press this? Point 0.75. 0.75. .75. Yes. Okay. Actually, this is working somehow. Slider. Slider, set single step, slider, set value. Set single step. Yeah, it's good enough. Actually, that's quite cool. Yeah. Nice, cool. So, we have a function that is called a single function that is called UI slider add with maximum value, current value. Label, prefix, and unit, and an optional parameter if it's two-sided or not. Oh, and it's fast and it's fine, yeah, cool. So now that's way better because now we have a direct connection. We get the sender directly, that's cool. Then we have to find the receiver, which is done in logarithmic complexity. So it's quite fast. Especially because there are only a few widgets in this list, and then we have the label info with all the stuff. So this struct is needed because we do not have this convenience function to just improve the object, the label object, so we have to bind the rest of the information to the label pointer somehow. So we cannot just find the label, but we have to find this block. Yeah. Okay. Good enough. Yeah, nice. Now, what else do we need? Yeah, that's quite everything we want. Oh, that's cool, huh? That's similar. Let's test something else. What happens if the stretch is added between the slider and the button? Now the button should be on the bottom. Oh yes, nice. And here we can make here we can make a nice. Here we can make print the plot. And the cool thing is, because we are an queue object, we can in this class we can connect everything normally. Oh, that's cool. Oh, that's nice. Cool. if we want to connect this button, we can just connect it to our to this class, because we are a file animating class, and the file animating class is a queue object. Oh, that's cool. We are not only a processing class, which is the main class of our system, but also we are a queue object, and this class is combining our whole system structure with the queued structure, and that's so cool. Okay. Oh. Nice. So that's a virtual function, that's a pure virtual function. Okay. Oh, I'm so tired already. Let's call this button save picture, or save figure, save plot. Later on we will have later on we will have a plot here. So the next step is to make a plot, I guess. Okay, let's see what we changed. We have a namespace qt. Alpha animating is now an object as well. We have a shutdown function. We have a slot that is called slider updated. Perfect. We can create UI slider add. We have a map, we have a queue label, we have a queue slider push button, fine. And group info for the label. Oh, nice. Add functions anim shutdown and UI slider add. And this UI slider add is a protected function. This means only derived function can use this. Derived processes can use this function. Okay. Slider update is a private function. That's okay too. Because we are we are in function slider updated, we know that this sender object must be a queue slider. In the mapping, we do not care if it's a slider or something else. It may be a text box or something. Should we add a label in any case? For the UI slider? I'm not sure. Should the label be on the bottom or on the top? I think bottom is nice. Yeah. Okay. For our example, we need something else. We need a button. We need a switch to turn on the signal generator and to turn off. Then we need a text box where we can enter the IP of the device. So we need a text box. need a function for this text box. Yes, I guess we should. Do we need... Yes. If we change the text box, yes, I think every text box needs a label, so we need another function. UI. How is this called? A text box. A button does not need a label because a button has its own label printed on itself. But the text box should have a label. Okay. Q text box. Q text edit. It's called text edit. Okay, nice. So we have a Q slider. We have doc Qt.io Q text edit. So we do not need the label anymore. We do not need the abstract slider, trigger action slider release. This is when the user releases the slider with the mouse. Slider pressed. No, that's fine. We don't need anything from this anymore. So, cool, and paint device. Type check-in and email, that's different. Yeah, I don't need this. That's fine. Map, we have everything from the map. And do we need something from the widget? Yeah, maybe. Text edit. So let's add a text edit. Q slider, Q text edit. And we say Q text edit pointer UI text edit add, and we need a label in any case, I guess. Const string, and we need maybe we need does a text a placeholder text. This program holds the editor placeholder text. Setting this program makes the editor display a grayed out placeholder text as long as the document is empty. By default, this program contains an empty string. Do we need a label? In any case, maybe it's sufficient to Is there a label? String label, yes, is equal to this. I think we should make it optional. Slider updated. Let's see. I'm not sure, but hopefully. Okay, we try to make. Damn it. Okay. q text edit pointer p text. We say p text is equal to new q text edit. If not p text, then return null. Yes. Then we have a label. Q label pointer p label is equal to p label is equal to new q label. If not p label, then delete p text and return null. If not p label, no. This is optional. P label, could we audit? This would be cool. Can we text? Yes, text. Let's make it easy in this case. Yes, string label. If string label dot size, then create the label. And if size and not label, then delete. String label dot c string. Oh, hello Reinventor. How are you doing? Oh, control reaches end of non-void function. Return. Nice to see you. What's up? Text. Yes, I'm fine. I think we have a decision made today, and I think it's Rust. I think it's Rust. It's very likely Rust. So yeah, I guess to 99%. Today I finished the Rust book chapter 2. I coded the guessing game, and I even used the Tokyo stuff to make this part in a new async function and stuff. Yeah, I'm quite curious. I think it's it will be interesting. I learned VHDL, and this is a hardware description language, and it's completely different to normal languages. And as you can see, the whole stuff is done completely parallel, and back then it was hard for me to think in that way, so I learned a lot of stuff by using this language. And maybe moin, hello Ezra. For everyone who doesn't know him, check out Reinventor of Wheel. If you want to know what, oh come on, shut down, yes, shut down Reinventor. Shout out, I'm so stupid. Reinventor of Wheel. If you want to see Rust and Go then you will find your answers there. And at the moment he's working on a custom-made keyboard. You're welcome. And hello, Asraja. Yes, I'm quite positive of the outcome, because Rust is we will not code Rust in the stream, but I will stick to C++. Maybe I'm quite curious if this thing makes me a Rust Jünger, what is called Jünger, like Rust, an Rustian, yeah. I'm quite curious if this is making me a Rustian, so maybe I will drop C++ completely, maybe not, I don't care, but I guess I will learn a lot, because this language is quite different than other languages like Go or Python or something else. It has special, special properties. For me it's very interesting how I will deal with the result return values, because I'm not sure if I want to use the match thing, but let's see, maybe it's a good language in your portfolio. I think it's good next to C++, yeah. Yes, I will not use Rust. I think I will not use Rust in my personal project, but the customer is using it, and I will learn a lot, I guess. So I'm quite curious and positive about it. At the moment I have to learn all the stuff. I have to learn about lifetimes, the borrowing system, and all the stuff. It's completely different, and it's not that easy. Match is very strong in Rust. Try to use it. Yeah, the only problem is Rust match without nesting. Yeah, sometimes I'm making. How can I avoid nested match statements? Are nested bad practice? Reinventor, maybe you know the answer. The match thing is cool to match all the outcomes, but is it possible to avoid match and the nesting of this is so looks so ugly, the nesting into match. To make things a bit cleaner is to drop some braces. What? Okay, this is the first one, but it's still nested. Yeah. Yes, but I don't want to. Yeah. Yeah. Ooh. Okay, I will close it, because tomorrow I have to learn Rust again. But now now I stick to this language. So at the moment we are coding a cute user interface for our simulation system. We are creating digital signal processing in the ESP32, and absolutely. I love this structure so much. I can't tell you how much. And at the moment we are working on this side. So the cool thing is that we, if we want to realize this project, we just have to check all the stuff we implement this, and we implement this, and this, and this, all the rectangles, and then we are finished, and then we are happy. And at the moment we are working on this rectangle. And it's looking quite cool already, because we have connected the slider to our label, and it's working quite fine. We have a Python version of this thing, and in the Python version we have Matplotlib on this side, and it's updated as soon as we change the parameters, and that's quite cool. And at the moment we are working on the C++ version, and this version is quite advanced already. So we create a function that so we can add a text box, and let's add a text box because we need the IP address of the device. So we make a q text edit pointer mp IP. The mp button will be changed to mp button save. And this will be called mp text IP. And we just want to create the IP text box. The IP text box is equal to this stuff. And should we make a label? Yeah, no, not like this at the moment. If not text IP, then could not create text edit. Fine. The mp text IP has a function placeholder text. Placeholder text is a Q string, but yes, set placeholder text, and the placeholder IP of or just device IP. Should we create stuff something like this? No, maybe yeah. So, and here we yes. Okay, let's do it like that. And then in the UI text edit, add, we make a Q label if we have a string label. If we have a string label and it's not p label, and delete text and blah blah blah. Okay, and at the bottom we can say we make a config of the label of the text. So we say p text no, we do not have to change the text, but we have to create the label. And no, we don't have to create the label because we just have to, and we do not need any association of the labels, so we don't need this. We don't need this because we have already created the label text. In this case, we cannot use the constructor because we have to make a special text in this area. The text box does need to be configured. So we just have to add the widget, the text box, the p text and the label. P text, and only if p label, then because if this size is 0, and then the p label is equal to null. Okay, So let's check. Does not have any field named p button save here, of course, because p button save. Oh, now we have a device IP, cool, but that's a big thing. Okay, it's multi-line. I don't want to have multi-line. Can we disable multi-line? I just want to have a single line. That's an edit class, a line wrap mode. Cute text box single line mode. You can use a maximum block count if you really want, but probably switching between the and Q line edit. Yes, this is what I'm looking for actually. Not a text edit, but a line edit. Yes. So we have a line edit. I thought something is strange because I can't. I didn't remember the text edit. Q line edit. Okay, so text edit. Oh, come on, text line. P line. Dude, I have to sleep now. Have a good one. Yeah. Thanks. Thanks for visiting, and see you next time. I will visit you and keep you up to date. Good night. Q line edit, delete P line, add widget, P line. What the hell am I doing? Slider update, set text. Oh, stop. Add widget, nice. Yeah. Set text. Slider add. Slider update. Yeah. Only these two. Not shutdown. Better instead of a line edit, let's do for counter from 0 to 20 using single clickable arrow. Yes, I know for the IP. I know what you mean. I know what not because I don't want to make this thing so special. This would be kind of maybe it looks better, but usually I don't use IPs, I guess. So we'll just use a line edit, but it's a good idea. Slider updated, line edit add, string label. But actually it is a good idea. Because at the end on this side I have to check if it's if the format, but the device is an IP. The device is an IP. Yes, the device IP. So text line IP. Text. Yeah, let's say text IP. A line edit add. Yes. The device is an ESP32. Yep. And I want to make a distinction between the base class. The base class should be as simple as possible, and the concrete class, this class should be as small as possible. At the moment we have 110 lines. The configuration of the user interface should be just this part. As soon as I am derived from phi animating, I get the whole structure and the whole convenience functions to easily add UI elements. I want when I start a simulation, I just want to say, yes, I have a new simulation. I want the base structure of the simulation, and in my concrete simulation, I want a button, a slider, and stuff. And then I can just use this and then print in the main loop. Is the ESP in the same network as the PC? Nope. Yes, sure, yeah. Q line edit. So I add the widget and I have a text. Yeah, let's see. Does not name it him. Q text. Yeah. Q text edit. Here we have a line edit. And as now I have a device. Now I have a text box. And yeah, nice. Okay, that's cool. What is happening if I add a label? Hello. Hopefully I have a label now. Yes. So I have an optional embedded people exist on Twitch. Yes. But only a few. People, yeah, embedded people are on Twitch, and only a few embedded people who are not coding in Rust. But they exist. This is the main structure we want to achieve, and at the moment we are working on this thing. So hi, I just say STI. You can check our repo. This code is available public on GitHub if you want. We have in C++ we have a base structure, and this base structure is used in every single project we are coding. It's quite cool. STI I can show you. If you have Telnet, then you can connect. Nigolus testing. You can connect to our ESP32. This is the process tree structure which is running on the ESP32 at the moment. So this base class, this processing class, gives us this structure, and it's quite cool because here you have on the other port we have a logging output. At the moment we do not see anything here, but you also have a command interface on this port, and here you can press help, and for every application we make, we have as many commands for on the in the application as we want. We can just register new commands. These commands are in every application, and these commands are depending on the project. You can just register commands and yes. And this is the new simulation application. So if we have the simulation is running at the moment, so in the simulation we have this structure, and in this structure we have a thread pool, and we have a simulation process and an interacting process, and the interacting process is essentially this user interface, and the goal is to make, I want to have a filtering process, a digital I hate this word, digital signal processing on the ESP32. We want to have two channels. The first one is from the ADC. We want to make this filtering process, the signal processing, we want to make it completely parallelized. We want to use two cores, and we want to use the SIMD instructions, the single instruction multiple data assembler instructions, to make an efficient signal processing. And on the other hand, we want to have a second channel from the PC simulation into the same path, and we want to be able to send the output to both the simulation as well as to the output of the ESP32, the DAC. And we want this thing to be able to we want to be able to build this system on the PC as well on the ESP32. So we are quite greedy. We want to have everything as perfect as possible. So this system, this part of the system, may be running on the ESP32 target. And if we are running on the 32 target, it's quite cool, because if we are on the target, then we have both sides. This side, in any case, we have this structure. And only if we are on the target, on the real hardware, then we have this code as well. If we are on the PC, then we just have this stuff. Only this stuff, and with this stuff, this is an application with a server, and the simulation can connect to the server, send samples to the audio processing, virtual ESP32, send the signals into the system, then the filtering can be simulated, and the output can be visualized in the simulation user interface. If we have, and that's the cool thing, if this thing is running on the ESP32, then we have both sides. In the usual case, we have an input from the ADC, then we have the filtering, and then we have the output of the DAC. But, and that's the cool thing, if we connect to the device with our simulation, then the output of the filtering process is not only sent to the output of the hardware, but also to the simulation. So we can monitor what is going on the ESP32. And if we activate the signal generator, then we have a input stream here, and the selecting process selects the stream from the simulation, because the stream of the simulation has a higher priority, because I can activate it. And as soon as I activate the signal generator, then it's using this stream instead of the ADC stream, and then we see our generated stream from the PC on the visualization of the simulation and on the output of the target. So that's the goal. That's the goal. And at the moment we are working on this, and this. I was about to ask what happens if both are sending samples. Yeah. So here we have an arbiter, and the cool thing is with this base structure, this structure is very cool. That's very cool, this thing. And with this structure we are able to create a picture of the system architecture which looks like this. We can just use rectangles and arrows to visualize our system. And this picture is created with Plan2ML. If you don't know Plan2ML, you have to check it out because it's so cool. That's Plan2ML, and I'm creating all the documentation with Plan2ML. If you want to check out the base structure, it's here, and the other project, the project we are working on is the ESP32 audio processing. You can check it out. If you like the project, I would appreciate if you can give me a star here. That would help the channel a lot, but no need to do it. So, but this structure is quite cool because we can make a documentation of the system quite easily, and then we just have to implement all the rectangles, and then everything should be fine. This thing is a Python application, and this Python application is quite old. And this application, with this application, I was able to simulate stuff, and it is using Qt and Matplotlib. And on Tuesday and today we are working on the C++ version of this application, and it's quite cool because it's divided into a part which is usable for any kind of simulation, and then we have the concrete part, and this part just adds the buttons and user interface elements that are needed for the specific simulation. So it has two parts, and yeah, the first part should the second part. The first part is the base class, and the second part should be as lean as possible. I just want to say yes, new simulation. We have a new simulation. Wanna know my favorite programming language? Yes, of course, sure. What I Kush Bramba. HTML, CSS, JS, SQL, Docker, Versal, Discord, White, Config.js. Aha. Yeah. What Discord? Discord? What Discord? Isn't it programming language, isn't it? I know HTML, CSS, JS. I would love to be able to code in these languages. I know Docker, and I used Docker. Docker is cool. I don't even know what White is, and Versal. SQL, I used SQL. Yes, a so cool project. I love this project a lot. We have a second project. The main project is if you have Telnet, you can connect to Telnet Navigalos USTO. And this is a gaming server, a multiplayer gaming server. It also uses the processing class. This is the core for every project, and this project is also using this structure, and yeah, oh, thanks respect back. The work as of yeah, absolutely, yeah. The whole life is working. The whole life is working your ass off. That's the meaning of life. I think. I'm so sad that I'm not able to code in HTML, CSS, and JS, but actually you can't learn everything. It's not enough time. It's a so cool stack, but I'm I'm on the bottom. My focus is on embedded development. So I'm on the tech stack. I'm on the bottom, but yeah, would be cool. But I'm not able to learn everything. So that's it. But at the moment we are. I mean, I'm an intermediate programmer. Oh, the Premigen is a cool guy too. I guess he is coding in Rust. I think he's coding in Rust. So we have created a cool. Yeah, started at the bottom. Now we are still at the bottom. Yeah. Hello everyone. I'm so happy. To see so many people. Now we have a big challenge. The next challenge is to create and bind a Matplotlib plot on this area. So in the phi animating, so this is the Python version, this is the Python version, and this is the C++ version. It's quite cool already. And here we have a text box. We can create the text box, and here we can't create the text box. So this is a function, an additional function we do not have here. But one of the main tasks is to create this plot. And I hope this is working. In the Python version, I did it like that. I included the Matplotlib stuff and the Python Qt5 stuff and NumPy and SciPy. But essentially the Matplotlib stuff. And as you can see, I also added Matplotlib backend, some Qt backend for Matplotlib. I'm not exactly sure how this is working, but I was able to. This is the UI base create function in the Python version, and the UI base create just creates the following. Without these elements. Do you have any takes on why AAA game companies are delivering less optimized games in spite they give backs to the developers? Because of money, I guess. It's all about money. Yes, I played a lot of AAA games, but sometimes indie games are cool as well. Some AAA games are cool. I wouldn't buy anything from EA again. But that's a different story. Yeah. I'm not playing as much as before because time and stuff and real life. But sometimes I'm not often, but sometimes I play if I find a really good game. Then latest Warzone mobile will fail because they made a game PUBG mobile which was launched in 2080, but still it's better than Warzone mobile. Yeah. Yeah, so I don't waste my time anymore for bad games. If I see a good game, then I play it. Otherwise, I leave it. We have to add a widget, but which widget? We have, what is this? A canvas of a figure. A figure, as you can see, a figure is a MPL Matplotlib figure object. It's a completely different object. An object not in the Qt stuff. Not in the Qt stuff. Oh, damn it. Okay, let's see. Oh, and I don't think that we will find something. Matplotlib in Qt. Embedding in Qt Matplotlib. So this is Python, that's the problem. But Qt sees it as a widget. The function is called addWidget, no? Yes, that's the strange thing, yes. In Python, at least, in Python. As you can see here, again, we have a Python stuff. In Python, we have the left side of our application and the left side, no, not the right side of our application makes an addWidget of the canvas of the figure. The figure is a Matplotlib object, but the canvas of a figure, of a Matplotlib figure, seems to be a widget somehow. So let's create the figure in Matplotlib. I'm not sure what I'm looking for. Matplotlib C++ for C++ documentation. So this is a different thing. Matplotlib for C++ is a wrapper. We at the moment we just have a wrapper. Yeah, apparently it is a widget. Matplotlib in C++. VBox layout, that looks cool. Widget with figure. Oh yes, oh nice, init layout. Canvas, figure canvas, oh nice, oh. Plotting from workspace, that looks promising. Oh, thank you, lol salad. That looks promising. So that's a figure canvas, new figure canvas. Figure canvas, cute. Okay, figure canvas. Namespace, mandate cute. That's this project. That's the namespace of this project. So let's see, how can I do it? They create a VBox layout as we do. Yes, we create in the base. We create a widget. That's the window. The first widget without parent is the root widget, and the root widget is the same as the window. So that's why we can use the resize and set minimum size functions. That's only working for a widget without a parent pointer. Then we make a grid, and then we make a QVBox layout as they do. And then plot layout add widget canvas, and the canvas member function is a pointer to a URL. Let's check if this is working. If we can just add this thing, hopefully. We have a grid and we have a pointer mp canvas. Let's see if this is compiling. Does not name a type. I guess we have to include something. I hope this is not because of this is not a member of this project. Is done by the finger class and the axis class. What do I have to include? That's the it's the backend. In C++, I don't know what to include, and I don't see it here. Mandate Qt widgets. Ample CPP. Use Ninja, only heard of it, only ever used makefiles in CMake. Oh yes, I can. I used makefiles, then I used auto tools. So from first I had with make files I had 8, and then with with auto tools I had cancer. So it was blah. It was so strange. So auto tools is really bad. It's old and it's blah. And then I tried to choose a new one. It's apparently from the project. Ooh, you. So this thing, object Python object. Point. Damn it. Okay. Yes, but it's okay. But because init layout, create Python canvas. At some point they have to Python. Okay. Python extract Q widget. Init layout. Yeah. Oh, that's cool. Oh, lol salad. Thank you a lot. I have to add this to the literature. And I will just add this so I save time for you. And STI, I can recommend Mason. Mason is so cool because Mason is like CMake. I switched from Auto Tools to Mason, and I was thinking about switching to CMake, but I used Mason instead, and it's so cool. It's a Python-like language. It's like CMake, but with a Python-like language. It's a language, and it's quite intuitive. It's easy to code. That's cool. Yes, lol salad, but your skill is better than my skill, it seems. Because I didn't know how you. Too bad. I despise Python. Oh, yeah. No, I think Python is quite cool to some extent, but yeah, I'm so happy that I'm able to make the same thing now in Python, because in C++ because it's kind of slow, and I have so many processes and code already in C++. I need my types. Yes, I also like types. Yes, yeah, and scripting. I wanted to learn Python. I learned Python because I wanted to have a new language. I wanted to. I'm often scripting in Bash, and I wanted to end this strange thing, but I wanted to stop coding in Bash, but actually Python was not the best replacement. I wanted to replace Bash with Python. For scripting it's fine, yeah, but I use new shell, so the new shell scripting is what I use. It's so amazing. Okay, new shell. Is this even a word? New shell. New shell pipelines to control any OS. New works on blah blah blah. Interesting. The cool thing on Bash is that I will check this out. MIT, cool. The main reason why I'm using Bash is because of this pipe thing, and you can create the process and stuff in Python, but not as beautiful as this. If you want to script something in the operating system, then this is the language to use, I think. Python is not a good replacement for Bash. It's a cool language, and you can do a lot of stuff with Python. I think Python is cool, but it didn't replace my bashing stuff. So they include a cube layout, and they include an MPL CPP backend Qt. Yes, I think. Yes, that's the same conclusion I got. So we need the back figure. What the hell? Create Python canvas from figure. Okay. We have a create Python, an existing Matplotlib figure instance. This is the repository. Is there some documentation? I want to use the official documentation. Help for compiling. Oh, Matplotlib. The section compiling explains the compilations of a program using the Matplotlib OH. Here we have the header. Here, oh no, stop. Here we have the header. Oh, come on, boss. Come on. So, copy. We need to remove this thing. Yeah, and then we include not only Python, but include this thing. Hopefully we have yes, Matplotlib, no such file or directory. Depends on what you do. For web requests, I would prefer Python curl. Yes, for web requests, I would prefer Python curl and get painful quite fast. Also, when you need to pass data beyond a bit of grep and regex, I prefer Python. Yes, I have the replacement for this type of for this stuff. I'm using I'm creating a C++ application, and then I use one of my common processes, because here I have two cool processes, the HTTP requesting, which is using libcurl, and it's quite cool to use, and it has HTTP built in and has structured and typed data. Interesting. And the second process I'm using is the file executing process. These two processes are cool for me. So it's in this repository. So this is not helping, but maybe this, and matplotlib.h not found. Python, yeah, Python dev. Let's see if I have to install something. Empt cache search. Matplot. Do we find something? Matplotlib. We need a C++. Is Matplotlib installed? I don't really know much C++. I usually use C after having to work with LLVM. C++ give me nightmares. Yep. This makes sense. I believe. Yeah, I believe you. Find. I actually heard about LLVM, but it's a compiler, right? I'm so stupid, but I don't know about LLVM. I heard about it. Matplot. We do not have any header Matplotlib, so we have to install this thing somehow. Is love, hate for me? There is times it just makes sense, and other times it makes me want to pull my hair out. Yeah, it's depending on what you see as C++. Here in this stream, I intentionally make the titles like ancient C++, so very old C++. I'm not using any modern C++. As you can see, it looks more like C than C++. I'm just using the SDL. I'm just using basic C++ stuff from the first standard, like the inheritance, and that's quite it. Yeah, you should use just class in the smart pointers. Yeah, that's stuff that is cool. You don't need more. You don't have to use all the fancy new stuff because it just has to work. So there is no header. What kind of package do I have to install? A compiler framework basically divides compiling in front-end, intermediate language, and backend. So all you have to do to get the compiler with a lot of optimizations is to build a front-end, convert from your language to the intermediate language. Cool. I try to use as many warnings and stuff to get a compiler with a lot of optimizations. Okay, I don't that's something different, which does tend to make compilation relatively slow. Okay, yeah, and depending on what you want, it can be fine. Matplotlib, matplotlib.h, no such file. When is a Matplotlib with VCP using? How can in the documentation there must be compiling a program explains the compilation of using the okay. Embedding okay, that's the mandate project, but I want to compiling a program in yeah, pip3 install matplotlib. Okay, fine. So default using no require satisfied matplotlib in these packages. It's fine. GCC basically does the same, just in wrong way. Zilong is not really slower than GCC. The header depends on the Python header and the corresponding Python library, libpython, and on numpy array object. If not in the standard include paths, the paths to the header files itself have to be specified for the compiler using options. Note that all Python containers should be same version. In detail. The Python header, Python, blah blah blah. Typical locations, Linux, We found Python, the Python library, NumPy array. By default, Matplotlib uses NumPy arrays. This requires the above header file. However, it is possible to avoid this header by defining without NumPy. Using Python 3, NumPy, include Python, user local, user local. We have to be in user local. I'm in user lib cd local, and then we want to find. I'm talking about Rust compile times that take a bit more because of LLVM 6. Even decided to step away from LLVM because of it. The customer I'm working for has decided today to use Rust as their new language for the new project. It will be a lot of fun. I'm quite curious how it will be. I'm at the moment I'm learning Rust. Tomorrow I will read the Rust book again. I finished my second Rust program today, but it's quite different. It's a lot, quite hard for me. The header depends on Python header. Why not use Ponylang? What is Ponylang? Rust is my favorite language, competing heavily with C. Oh, cool. Yeah, I'm quite curious. It's quite cool that they chose Rust, because I want to see what Rust can do. I will not code Rust in the stream, but we will see. Maybe it changes me completely, because a lot of people who work with Rust are very satisfied with it. At which point where do we have the Matplotlib apt cache search package to file provides a file search file apt file, yeah, apt file to install, apt file update, yes, that's it. That's what I'm looking for. Apt file update and install apt file. Yes, come on. Honestly, most people get lured in by the promise of safety, but a lot of the people who stay also stay for the tooling provided. One moment. Apt file update. Lava, what's lava? Matplotlib CPP, lava, matplotlib. Welcome to possibility simplicity. Plotting lava is built to resemble the plotting API used by Matlab and Matplotlib. Oh, nice. Wow, that's no nice. They have the header in the repo, at least. Yeah, they have the. Oh, that's fancy. What the hell? Nice. XKCD. Cool plot XKCD. What the hell? Nice. Apt file search. One moment. I want to see if there is any find. If there is any find matplotlib.h. As you can see, what? Yeah, not H, but HTML. Isn't it my? Yeah, it's .h. Okay, maybe. Yes, CPP. You're right, Arman. I'm so tired. Ooh, already. Matplotlib CPP. That's strange, because frequent problems. Well, hopefully how to resolve. Matplotlib cpp.h. There is no mention of this repo. Usage. Plotting. Plotting API used by how can I install? Installation. apt-get install matplotlib numpy. Simple works by wrapping the popular Python plotting matplotlib. This means you have working Python installation, including development headers on Ubuntu. So it's installing the matplotlib with this package. Oh, no. Python numpy. Python 3 Matplotlib, yeah. Steal the header from yeah, stealing the header is not, we have to install something, I think. Manually installed is already in the newest version, set to manually installed. So strange. Inline backend for inline use in Python Jupyter. Matplotlib cpp apt cache find matplotlib cpp. Apt cache search. So you think this is the repo I have to install? I want to both Python and how is it? File is currently. I want to see the link between this Matplotlib cpp. This is the documentation to Matplotlib for cpp, C++ writer wrapper. The code is organized in this. Yes, as you can see, the code is organized in this GitHub repository, which is a fork of that repository. Lava. Okay, now, so this is the base. This is the base repository. That's the first one. And this is a forked from Lava Matplotlib. And the documentation refers to the fork is outdated. The fork is updated, you say? Outdated, you say? Damn it. 3 years ago. In both cases, this is not the best thing. Oh man. Oh, that's a bad outcome, because they are both outdated, aren't they? Yeah. Okay, a lot of more stars, at least. Activity. I think the header is not really binding the library, but actually implementing a lot of stuff in the header itself. If you look at it, it has a lot of functions and stuff in there. Okay. Here's the header on the root. Python header must be included before any system header, since they define POSIX C source. What they define POSIX C source? What's that? Is this a header only thing? What kind of this is MIT license? Okay, and Matplotlib has a BSD license, I guess. This seems, yes, as you say. I think you're right. Contribution, CMake, yeah, that's a header only thing. This looks quite promising. Okay, yeah, lol salad. Sorry, it took me too long, but it seems that you're right. This would be cool if this is only a header file, then It looks like that, but maybe you don't even need the header, but just still prefer that you need. Yes, actually, in this case, I just want to Python function histogram. Oh yes, the Python header. Oh yes, this header does all the dirty work. Yes, this thing does all the dirty work. So like it's mapping, yeah, it's wrapping all the dirty stuff. Ah, and that, ooh. Oh, come on. Ah, no. I don't want to. Ooh, yes. Fuck. Yeah. No, no, I don't want. Matplotlib CPP17. Okay, I want a package, a C++ header only library for what based on PyBind is and yet another C++ library for Matplotlib featuring more functionalities than Matplotlib CPP. More functionalities, more. It is supposed to provide the user with almost full access to Matplotlib features in C++ by implementing as many wrapper classes of Matplotlib module as possible, like axis, figure, and its primary advantage over conventional Matplotlib CPP is that the user can pass a variety of arguments as in the form of args and qargs thanks to PyBind 11 without the need of conversion to more flexibility. Installation. For using from CMake lists, the hello world example, find package, blah blah blah. 5 months ago. Let's give it a try. Let's give it a try. Yes, so plots a figure. Oh yeah, figure. Oh, holy. Because we also have to bind this thing to the cute stuff. Ah, come on. Yes. And I think yes, we can achieve this in in a lot of ways, but no, there is no clean one because we don't have a Linux package. So we have this dependency to this repository. But let's give it a try at least. Yeah, alternative. It's more up to date. Yeah. Okay, let's just check it out. Git clone. It's a header only thing. So at first I'm doing I do it dirty way. So we add this thing to the components common, because here we have the file animating stuff, and then we copy this thing. It's a header only. Where is the include? Okay, it's not only header only, but it has many headers. Access, yeah, Matplotlib, PyBind 11, common. Which one do I have to include? Examples, hello world CPP. Pyplot, okay, let's include. So I copy the stuff here, then I include Matplotlib 17 pyplot.h. Is this working? No such file. PyBind. Yes, we need PyBind. apt cache search PyBind. PyBind 11 def. Okay, do we have a package config? Hopefully. Find PyBind. Yes, do we have? Yeah, hopefully this thing is. This is the type of situation where I would be missing the Rust package manager. Yep. That's a good, yeah, that's a good situation. That's true. What? Audio processing, what? No, we are in the simulation. We're in the simulation, Meson build. And here, now we have the dependency PyBind 11. PyBind not found. What? PyBind config not found. What? Found package config? Runtime dependency PyBind 11 found. Found package config. Found no package config. Yeah, okay. Should we install something like this? PyBind config. Do we need a PyBind config? Helper module. I don't know. But apparently this is an absolute pain to get working with Qt. Yes. Maybe. Let's check. Where is a package config? Package config file. I don't see a package config file anywhere. How does this thing know that we need a package config? PyBind package config. Not found. Should we add this thing to config? Try to begin and CMake. Okay, okay. This information is in the config CMake. Okay, so we vim lib CMake PyBind PyBind 11 config CMake. Okay, what kind of package do I have to install? PyBind 11 config install. Yeah, couldn't find PyBind config. Pip install and using blah blah blah. I'm not very sure PyBind. In my zip I couldn't find any. I mentioned an integration too. I hit the same problem. Nice. File missing for the solution above is not going to be solving it for me. I removed the pip version and installed the conda version. I added. Oh no, Anaconda. Yes, that's okay. That's special. If possible, please improve. There's still no way to install without conda. Same issue here, still can PyBind. Sea Lion. Isn't the problem simply adding a rule? Just adding it to the repository. I'm not sure updated. In the installation Install environment with content is the only straightforward solution so far. Interesting. Okay, 2020. Many people are complaining. The link is broken. Okay, this I was able to fix the problem by installing Python. Okay, this package. Let's install this package. Python 3 pipeline 11. Okay, now let's check if this is working. Come on. Yes. Oh, look. Easy. Pipeline found. Yes. Oh, everything nice. Yeah. Okay. So, but now, what do we have? I guess we have to compile with, yes, we have the 17 version. That's fine. Yeah. Okay. So this thing needs a package. What kind of package? Just want to check this again. Okay. Whatever. It's working. Okay. What did we need? We needed, or I have to make notes. I have to make notes. We installed this thing and we installed something else before. Not this. Yes, pipeline dev. Okay. So to keep track of all stuff. Okay. Nice. So now we have an object wrapper. What is declared with greater visibility than its base? Here is the even more hacky way. Yes, embedded Matplotlib insert cute C++ file.pro. Sources, Q application, Q main win. What? Lol salad. What the hell did you find? That's an interesting way. That's an interesting. So that looks interesting. Just run Python code, my brother. No, is it this hacky? Where is the link? File Pro. String code import. Yes, Python canvas. What the hell? Yeah, no. String code. Py-run simple string. Py-run simple string. Yes, but cute widgets. Okay, clicked access plot and move. Yes, Python code win show win, but it can access the C. Can it access the C++ version? No. How? Initialize. Python cute. Python cute. We have a constructor. This is the constructor. Set program name. Python initialize. Initialize. Okay. Initialize, and then we have a code, and then simple string, and then it's not derived from anything. Python cute. Okay. Set object name window. Main window is win. We have a Q application. we have a window, we set the object name. Python code, and then WinShow Python code. It's just creating this thing, and this thing has a constructor and is executing immediately the simple string. And the simple string, oh no, it's referencing the, I guess, the main window somehow. For widget in all widgets. Oh, that's too nasty. That's the import system path. Lib dynamic load. Import matplotlib. Use Qt5agg. Yes, and then it's searching for the main window, and it's plotting in the. Okay, this is the point where I think I don't know if I want to plot. How can we plot something? Cute charts. Let's look at what the charts can do. Audio samples. Yes, actually. Yeah, I guess Matplotlib is not easy as expected. Yes. Yes, I think this looks kind of nice. This looks kind of nice. Yeah, the problem is that Matplotlib is quite advanced. Add axis, attach axis. The only thing why I wanted to use Matplotlib because. Oh, thanks for looking, by the way. The reason I wanted to use Matplotlib at first, what is this text edit? Line edit, was I'm not sure if Qt can use, for example, double signals and stuff, 2-axis, new value axis. Let's check. Let's check how good the documentation is. Qt charts, multiple axis. Is this button using multiple axis? Yes. New chart. Add axis. Align bottom. Oh yes, yes. Let's give it a try. So the Matplotlib, that would be cool, because then yes, we would remove a dependency. This looks kind of cool. Okay. Back to the roots. So we have seen. Oh, I have to add the links, because you found the links. I want to at least save them. Thanks. Lava. So this is, what is this? This is from the Lava repository. This is the Matplotlib 17 version. Okay, Matplotlib CPP of Lava. Cryoris, Lava, Soblin. That's cool. Then frequent problems. Not using it. Matplotlib, Mantis, we saved Mandit already. Okay, so charts, cute, 6 charts. Okay. But it seems like it's not supposed to be used from C. It although looks like the swiper function may use the Python API to basically. No, really? You think? that would be bad. Okay. When instant using package, blah blah blah. Check the comment properly. Package. Okay. Let's try it. So at first we have to remove all this stuff in the Mason file because we do not want to have a Python 3 anymore and Python bind. We just have the Qt6 GUI, the core, the GUI and the widgets. Hopefully this is enough. And then we remove from the Py animation so the dependency Qt charts question mark. Map Python, we can remove all the Python stuff. And then let's try to. Yes, now we can compile again. And now we try to use the direct way with Python charts. Let's add a Python graphics widget. So module provides an easy to use chart component. It uses the Qt graphics view framework to integrate charts with modem. Now we are back to 2 hours ago. Yes, yeah. No, we are not. Because we have wine. We have wine and that's... So the state, the emotional state will be different now. Listen to that sound. Oh yes. So, but now we have a different state because now we know that we are not using Matplotlib. At least we have the information that it is quite hard to integrate Matplotlib in C++. So it's a different state. Thanks. And see you. So I will prepare this stuff. We have a graphics widget, hopefully. Graphics widget class, okay. So graphics widget class. Yes, okay. Include graphics widget. Let's try to add a graphics widget. At first, just for testing. Okay, we have a graphics widget. Grid layout, I want to have this here. And then after the grid, yes, after the grid we have an MP graphic. Can we compile this thing? The header is found. We initialize the pointer, the graphic. So what can we do with this graphic? Users can easily create impressive charts by selecting one of the themes. Chart is an intuitive tool to show charts in computer applications. This example shows how to create a simple line chart. Okay, chart view import. Oh, that's articles and guides. Okay. GNU General Public License 3. Yeah, that's cool. That's fine. Okay. C++, API reference, C++ class, back. Okay, I have included the graphic, at least it's finding the header. So let's try to Qt chart detailed descriptions using namespace. Oh, it's a completely different. Charts API is built on chart view. Chart. We have a series, a Q line series. Let's try to. Maybe I just have to include the Q charts. Let's try to, if we need a graphics widget. Do we really need a graphics widget? Let's see. If we just can include Qt charts. As you can see, the header file has a different name already. So no such file or directory. Yes, that's interesting. Yes, that's a Qt charts module. Installation on Ubuntu. I guess. So, okay. First we have to check. I guess now we need a new package which is called charts. So we try to not found. Yes, expected. apt cache search Qt6 charts. Chart. Oh yes, libqt6 charts def. Apt install. Yes. Now we should find this thing hopefully. Oh, I want to. It's not in the base. It's a base package. That's interesting. Oh, we found runtime dependency. Oh, that's nice. Runtime dependency Qt6 just found. That's cool. But now useless cast. Yes, useless cast. We have to add argument plus equal. This is a system header as well. Qt core. Qt core, but yeah, this one. Q widgets, Q core. Useless cast. What? Why? Why? We should have declared this thing. You can probably also remove the Python system header stuff. Python system header. Yes. Oh, thanks. Oh, thanks. Yes. Perfect. Python. Okay, thanks. Thanks. I didn't see it. So we had a warning in the widgets, and we removed the warning with by telling the linker that this is a system header, and we do not want to apply all the warnings for the system headers because we cannot guarantee that this is not making any stuff like this. Useless cast. This main integrate and Linux charts. Okay. Core, and it's in the core, but I think maybe we also need the charts. Header, yeah, I think we also need this chart, the charts, hopefully. I hope this was the problem. Oh yes. So step by step, moving forward, step by step. It's always pain in the ass. Oh look, core GUI widgets charts. Oh, the same version everywhere. Nice. So okay, so we have installed a package, the right package. We have found the package in Mason. We have the system header include. Fine. And now the interesting part is that we only include Q charts, and because not Q charts, but Qt charts. That's different. Interesting. But now this thing knows what a Q graphics widget is, although we didn't include it. So this Q graphics widgets seem to be included in Q charts as well, because somehow it knows what this thing is. That's cool. So now yes, we're using Q charts. Why not? Maybe Q charts is everything from the library. Yes. So let's see. Yes, to link against the Qt module, this is for the key. If you use QMake, then it's included like this. That's the CMake equivalent. And here we have a Q line series. Chart view, add series, create default axis. Using the module, this is the QML version. Using an American linking yes, and there are two other dependencies. Several build tools have dedicated support for this, including CMake and QMake. Building with module evaluation, articles, charts overview. Let's do charts overview. How to create a chart. The QChart class different linear and execute is a QChart is a Q graphics widget that can be shown. Okay, maybe we just have to create a Q chart instead. Q chart, because it is a Q graphics widget. So then we have to call this MP chart. Is not the namespace name. What the hell? What? Why not? Okay, that's interesting. The namespace is not working somehow. I don't know why, but okay. But at least it knows what a Q chart is, and it seems to be a. So we create a chart. So chart, yeah, fine. So we have a Q chart, nice, and this is the Q chart class. And what do we need? Do we need a parent? Is null pointer? Yes. Okay, fine. This seems to be a Q graphics widget, and this means it's a widget. We should be able to just create this thing. We have a grid layout. In the Python version, we have a Q VBox layout, and then we have a Q grid layout. What is the function add layout? Okay, we have a grid layout. We didn't do anything with yes, we have to add the graphics widget to the grid layout, and we have to add the grid layout to the window widget. Did we do this already? We have created a window, then we have created a grid. We window, that's strange. We shouldn't add layout. Oh yeah, stop. MP, what? Stop. I'm confused. We have a window, then we configure the window, then we have a grid, then we link the grid to the window, then we have an option, QBox layout, and we link the option to the grid. Oh, it's so late. The whole day coding and coding. Here we have the QBox layout options. The QBox layout is linked to the grid. The options are linked to the grid. Add layout. Okay, add layout and then add widget, same but different other order, I guess. Now we just have to, this is an add layout, and then we can add a widget, and the widget should, okay. I think I know what we have to do. Add layout, opt. Columns, column stretch, yes. So now we say mp chart is equal to new q new q chart, new q chart. Then we say if not mp chart, then could not create chart. So hopefully this is compiling. Yes, okay, we are able to create a chart, fine. Next step. We want to add to the grid, we want to add a widget now, because now we have a widget, and this widget is the chart widget. And then we have two columns at the grid. We add, if we have a grid and we add something, this is kind of a widget, but it's not a widget, it's a layout. So the outer layout is the grid, which divides the thing into two sides, and then we have different functions for layouts, adding layouts to the grid and to the outer layout, because this is a grid layout. We can have a layout in a layout. So a layout is a container. It's strange that a layout should be a widget actually. No magic function to call add widget q chart. Why? Because this is a graphics widget. Graphics proxy widget. Graphics widget. What? Huh? Chart class, graphics widget. Graphics widget is a proxy inherited by inherits graphics widget. Inherits object, graphics object, and graphics layout item. Okay, so we need to add to a grid layout. We have to add a graphics layout. So add item, layout item. What's a layout item? We have add layout and add widget. Maybe we should use add layout. Yeah, no chart. Oh, cute. Adding chart to grid layout. Charts in grid layout. How do you display chart view in a custom widget? Because the chart view widget without the boundary. Things, in fact, when I change grid layout into add widget chart view, and chart was present. Okay, add widget. Yeah, add widget mp chart. Chart view. Now I know what the chart view is. Here we have the chart view. Oh, has no member chart view. T chart. What is T chart? Cute is chart, and okay. We have to create a chart view dependent on a chart. Okay. Yeah, sure, why not? You can have everything chart view. No need for a chart view, I think. You don't think? The strange thing is I saw it here, chart view. I think we need a chart view, because here in the example says we are working on the chart view. I will just try. Yeah, add widget. You're missing parameters to add widget. No, add widget. No, actually, if I just use, no, I think if I use it like I did, row and column. That's strange. Why and if this is the case, why don't I need this here? What? Add widget. Add widget. Yes. Yes. I think you're right. Because that's wrong. Add layout. Yes. Oh, lol, Salad, you are the master. I think you're right. Yes, I have to remove this. No matching function to call. Add widget. I think you're right with this. This was missing. This was missing in any way. But now I'm quite convinced that we need a chart view. You too? I think. I don't know, maybe you can try. Okay, and then I try QCharts classes. Okay, we have the the grid layout, Q graphics. So he wrote that, okay, we need a new chart view. So I think this is the last part we will do, because I'm so wasted already. I'm so completely wasted. So MP view, fast mode is new. Q chart view, if not view, oh come on, then could not create chart view. Okay, so the link, this chart view, so we need a chart view. Yes, and if not, then we have to directly delete the MP chart. But if we have both, if we have, okay, we can use this as parent, or can we add, I would like to, no, yes, yes, I think this is okay. And then we have, we should MP view. Does this make sense? If not, if we were not able to create this, but we were able to create this, then we have to delete this, because okay, so add widget, a view. Let's see. Ding. Oh yes. So we have a view. Now we have a view. Nice. So this, yeah, this looks nice. And now this means we have a chart view, and this chart view must be accessible to the derived classes. Now the last thing we will do is that we draw something on this view temporarily, and then I will commit all the stuff. Okay, so here we have access to the view, the MP view, and here we create the plot in the example, and then this is it for today, because I have to go to sleep. I'm so tired. Oh, come on, stop. Copy. Oh, come on, stop. Stop. P series. Oh, come on, stop. So. P series is new Q line series, fine. And then we append something, I don't know what this is. And 2 and 4. And then we should be able to just add the series to our MP view. And the view, and then the, oh. Yes, but I think we don't want the view, but we want the chart itself. So we want to have the MP chart actually to access. So this, we have to change. After the grid, we want so the view is private and the chart is open. The view is private, but the chart is open. we access the chart directly, add series, and then chart create default axis. So if this is working, then I will go to sleep because I am so tired. Ugh. So. You're faster than the compiler. You're faster than the compiler. That's amazing. So amazing. And next time we can change parameters, and then we can see. Yeah, that's beautiful. So as you can see, good night. Yeah. Thanks for watching, and especially thanks to LOL Salad today for helping me that much. As you can see, the base class should implement all should implement all the nasty stuff and difficult stuff. And here we just want to create the series. We want to concentrate on what we want to actually print. So we have a chart, we have everything we need. We have an option area and we have a chart area. And these two things, we only need these two things, and we can just, that's the minimum set of stuff we need. What kind of UI elements or widgets do we want? And that's the printing area, and that's everything we need. Okay, yeah, cool. Thanks for watching. Next time on Tuesday, I will commit all the stuff today or tomorrow on latest. Have a good night, and now I can sleep. Thanks for watching. Bye.